do this 2022 scholarship question. So it says, consider the equation x square minus 4x plus 10 is equals to kx plus 1 whole square, where k is real. For what value of k will the equation have two distinct real roots with the same sign? So two distinct real roots means discriminant is greater than 0. Discriminant is positive. Same sign, we will do that. So with the same sign, we know that if alpha plus beta, if alpha and beta are the two roots, alpha plus beta we know is minus b over c. So here the sign will not affect anything. And the other thing is alpha times beta is equals to c over a. If they are of the same sign, in both the cases, if both are positive signs, it will be greater than 0. And if both the roots are negative, it will still be greater than 0. Cool. So here we are going to use this later in this question. So whenever you read a question, try and bring back whatever knowledge you have in the question first. All right, so let's start with the equation and find the values of k. So we have x squared minus 4x plus 10 is equals to kx plus 1 whole square. Let's expand the bracket first. So x squared minus 4x plus 10 is equals to kx squared plus 2x plus 1. Again, I have used a plus b whole square, a squared plus b squared plus 2ab. Cool. Now let's expand the bracket one more time with the k. So it's going to be kx squared plus 2kx plus k. Cool. Now let's bring everything to one side. So we will have 1 minus kx squared as a coefficient of x squared, plus, let's keep plus, then just it's easier to compare with the equation. So it's going to be minus 4 minus 2k x plus 10 minus k is equals to 0. Right, so now I have converted the whole equation into another quadratic where it's ax squared plus bx plus c is equals to 0. All right, and we know that our quadratic formula is minus b plus minus square root of b squared minus 4ac over 2a. Right, so we're going to use this formula now. So your roots will be equal to minus b will be minus of minus 4 minus 2k plus minus square root of b squared minus 4 minus 2k whole square minus 4 times a times c over 2a, 2 times 1 minus k. Cool. Oh, we didn't have to do this because we just had to prove the discriminant is greater than 0. Sorry, so let's delete that, and we just need to, because they have given that the roots are greater than 0, we just have to prove that discriminant is greater than 0. So we have to do b squared minus 4ac is greater than 0. So b squared will be minus 4 minus 2k whole square minus 4a and c. This is greater than 0. Cool. So now let's do the squares. So minus 4 squared is 16 minus 2 times a times c is going to be 16k. It's going to become plus because there are two negatives, plus 4k square minus, now here 4, let's open that bracket first. So it's going to be 10 minus k minus 10k, 10 minus k minus 10k and plus k square greater than 0. Cool. 16 plus 16k plus 4k square minus 40. Minus k minus 10k is minus 11. Minus 11 times minus 4 is plus 44k. And then minus 4k square is greater than 0. Cool. So here plus 4k and minus 4k can cancel because it gives us 0. 16 minus 40 is minus 24. 16 plus 44k is going to give us plus 60k is greater than 0. So 60k greater than 24, k greater than 24 over 60. If you simplify this, we can get 12 times 2 and 12 times 5. So k is greater than 2 over 5. That is our first value. All right. So that is the value that we have got. Now they also say, so this is when there are two distinct real roots, right? So that was one of the conditions. The next conditions are they are of the same sign, right? And at the start of the question, I did explain that if alpha and beta are the two roots, alpha plus beta is equals to minus b over a, which is not being affected by the signs now, but alpha times beta is equals to c over a is always going to be greater than 0 when it is same sign. All right. So here we will now do c over a is greater than 0. So if we go back to the equation, we have c is equals to 10 minus k and a is equals to 1 minus k. So 10 minus k over 1 minus k is greater than 0. Now for this whole equation to be greater than 0, we need, if our k here, all right, so we need both numerator and denominator to be either positive or both to be negative, right? So if on the top we have 10 minus k, right? So here this k value, if this k value is greater than 10, sorry, if this k value is greater than 10, if this k value is greater than 10, it's going to give us negative, right? So if that is going to give us negative and we have 1 minus that greater than 10 value, right? So both those values are going to give us negative. So let us suppose that value is 11. So let's try. So 10 minus 11 over 1 minus 11 is going to give us minus 1 over minus 10. And that is going to give us 1 over 10, which is greater than 0, right? It's a positive value. So that is possible. For the next value k, so if here, if k is less than 1, if k is here, the denominator, if we make that positive, if k is less than 1, all right, at the top it's going to be 10 less than 1. So let's try with 0.5. So 10 minus 0.5 over 1 minus 0.5 is going to be 9.5 over 0.5. It's again positive. It's again greater than 0, right? So two other conditions are k greater than 0, and this is going to give us a positive value always, right? So these are another two limits that we have got from here. So now we can say that the values are k is greater than 10, right? And so we have found here that k is greater than 2 over 5. right? So 2 over 5 is 0.4, right? So, and here we have k is less than 1. So k is less than 1, but it's greater than 2 over 5 because it cannot go lower than that. It cannot be negative because that is the question. In the question, it needs to be greater than 0, right? So these are all the limits that you have, the values of k. So this is all the values of k that you can have. All right? I hope this makes sense. All right. Have a good day.